Alright, so I'm going to start off by just showing the usage of this stuff and kind of the mechanics on a high level here. So I'm making this applause sound. It's kind of like a sound call, but more like one voice, one buffer is in a sound call, so it's pretty simplified. So it's putting this applause resource into this, or applause buffer, and getting a sound from the, or getting a voice from the voice manager, and then in this next call, it's getting the same buffer, getting a new voice and a new handle, so it's a separate thing. And then it's doing the same thing. This is electro, and then I show you the removing here to show that the reference counting is good and the handles. So we go through here through the first two things. First two additions here, it does the first applause. It's this buffer, this 116 ends with 54. Same buffer on the copy here, and the rough count goes up. It gets a new voice, and it has a different handle because it's a different sound call, quote unquote. And then it does the same thing for electro. And then here, it'll remove that for demonstration purposes. So it made this electro up here and then removed it. And you can see it's the same buffer. The reference count went from 2 to 1. The voice was returned. The sound was destroyed. The handle was destroyed. And that deletes the pointer in there as well. And then next up is this Seinfeld business here. I have my callbacks going in via command patterns. So this sound object gets created with the A section of Seinfeld, and then you submit a callback to that, which is this just callback command I made, transition on end. So for you give it A, you tell A start transition on buffer end is baked into this command, and then same thing for transition. So I'll just show that works. I'll just do the thing. Then the last thing to kind of show here is a more crazy thing. I kind of combined a bunch of the requirements here into this thing. So there's the attributes here being modified for the sounds. There's a timer system. I put in some tweening just because I wanted to. It's really dirty right now. Yeah, so there's panning, volume, pitch, looping, playing, and so the way that this works is that the second parameter is the time, so this is 0 milliseconds, and then this one gets fired off at 7,000. So yeah, so what's going to happen is it'll pan across the first thing, and then it'll do this stupid linear fade because I can't figure out logarithmic interpolation of values yet, and then it'll do a weird pitch thing on the next part, and then it'll tell the applause to loop, and then it'll tell it to stop looping. So it'll loop once and then stop. After this breakpoint. And it didn't loop again. So that's all the high level stuff. I'm going to keep going into some of the how the systems work, but if you don't need to see that, feel free to stop. So I made a class diagram for my voice manager because it's kind of crazy in there to get it to work with. I just wanted to make it work with multiple formats because I thought it would work, and I saw resources about people talking about making a voice pooling system that accepts any sort of format. So when a sound is loaded, I tell the voice manager, all right, here's a format from this buffer we just loaded. Do you have a pool of voices that corresponds to this particular format? If you do, all right, fine. And if you don't, then it creates a pool of a bunch of voices through a factory, and that's where the active and inactive, the returning stuff came in that console call earlier. And in there, there's an associated callback because the callback has to be associated with the voice that it used, that it was created with. So when you give a voice to a sound, the sounds was like applause, electro, that was all. Those were sounds, and they had a voice, which has its own callback thing, which you submit commands to, which is how I did the callbacks, and then it also has a voice that you can use to do the voice stuff. And so that's the voice manager, and the buffer manager does the MD5 search right now. It doesn't really do the uniqueness thing, like hashing the audio data to MD5, if that's how you can say that. But it does do you're not searching a string, you're searching the MD5 hash of a string. So the buffer manager just has a list with MD5, with like little structs that have MD5 and the buffers associated to them, so that's how they're accessed. Timeline is just this kind of guy here. You can register things, deregister when they're done, and this process gets called in the Azul loop right now, but when multi-threading is going on, I'll probably do that inside of the audio thread. And handles are, I think, the last thing, or second to last. Handles are, just the same as in those demos, really. I just kind of made it work. Instead of dogs, it's sounds. And so the sound has a handle, and it was your idea, so you know how it works. And it does the attributes through this voice stuff here. The panning is probably the most complicated one. It doesn't just have a single line of code, but the rest of them are all just telling the voice to do stuff. Yeah, I think that's it. Cool, thanks.